Today we're looking at math lesson 14.2, partition shapes into equal areas. So what does it mean to partition something? What?
Like in half, like you put it in groups.
Yes. To partition something is to cut them into different parts. You can read let's read our I can statement together. I can divide shapes into parts with equal areas and write each equal part as a fraction. So, now today we're doing in equal parts. To partition something doesn't necessarily mean it has to be in equal parts, okay? Today that's what we're working on so that we can make fractions. Mia designs a playground. She plans to divide it into 4 parts with equal areas. So far, Mia has found one way to divide the playground. Show another way to divide the playground. Explain how you know that 4 parts of your plan are equal. Okay, so you're going to work for a little bit and divide this one that says my plan into 4 equal parts. Okay, so we had a little trouble because some people tried to divide it using vertical lines, and there's 14 squares, and that's not divisible by 4, so we can't do that. So most of you finally came up with dividing it horizontally and then going 7 boxes, 1, 2, 3, 4, 5, 6, 7. And dividing it vertically that way. Okay? So if you are still struggling, go ahead and divide it that way. And then it says explain how you know. Well, I know that this is a 4 by 7, which is 28 square units. And this is 7 by 4, and that's 28 square units. And it's 4 by 7 all the way around. So that's how we know. Please go to the build your understanding. How can you divide the rectangle into 6 parts with equal area? How do we know the parts? Okay, so divide that into 6 parts with equal area. If you're home, stop your recording and do that. Okay, so I didn't really see anybody who had it divided into 6 parts in the classroom here. So the first thing I'm going to do is count how many down. How many squares down do we have?
16.
1, 2, 3, 4, 5, 6, 7, 8. Can we divide 9 by 3?
Yes.
And what would that be? 3. So I'm going to come down 3 squares and I'm going to put a line. And I'm going to come down 3 more squares and I'm going to put a line. Now, I have 3. How can I get that to 6? 3 times what is 6?
3 times 2.
2. So it is 16 across like Avery said. So if I go 1, 2, 3, 4, 5, 6, 7, 8 boxes and draw a line straight down, I now have 6 equal boxes. So they are 3 by 8. They're all 3 this way. They are all 8 this way, even in here. So they are all 24 square units. So there are some questions to be answered with this. Says, how do you know these parts are equal in area? What did I just tell you? They each covered what? No. How many square units? So what fraction of a whole rectangle is each part? Okay, each cover 24 square units. And the next question is, what fraction of the whole rectangle is one of these parts? So what fraction of the rectangle is this square? No. How many parts did I?
24.
Thank you. I drew around one part and there are 6 parts. So your rectangle is 1/6. And this could be 1/6, right? Each little box could be 1/6. And together we would have how many 6 if we added 1/6 6 times?
I don't know how many.
We would have 6 6. Divide this circle so that each part is 1/3 of the area of the whole shape. How can you show that each part of your circle is equal in area? How do we divide a circle into 3 shapes?
Y.
How do we divide a circle into 3 equal shapes? An upside down Y or a right side up Y? It's kind of hard, right? Okay, I just need you to do that the best you can. It may not be perfect as if we were measuring it. Okay, so I think maybe I should draw that darker so we can show it. Okay, now I can't count my unit squares here. How could I figure out if these were equal parts?
You could cut them out and then stack them.
Okay, I can cut them out and then stack them on each other and see if they match, right? Critique reasoning. Angela and Pedro divide rectangles into 8 equal parts in different ways. Both rectangles are the same size and shape. Do the parts from Angela's rectangle have the same shape as the parts from Pedro's rectangle? Do they? Are they the same shape? No, they do not have the same shape. Okay, so to explain, no, they are not the same shape, and the parts of Pedro's rectangle are shorter and wider than the parts of Angela's rectangle. Who divided the rectangle into parts that are of a greater area, Angela or Pedro? Does anybody tell me? Rhiannon.
Neither, because they both have the same, because Pedro's are linear and wider, but Angela's way is like shorter but thicker.
Okay, they're both divided into the same size rectangles and into 8 equal parts. It doesn't matter if the rectangles are a different shape. So it says whose parts are greater, Angela's or Pedro's? Neither. Both rectangles are divided into 8 equal parts. The shape does not matter. Number 1 on the check your understanding. What fraction of the total area of the circle does each part represent? So if you shaded one part of this, what part would that be? 1/4. Okay. So you should write 1/4 on there. 1, 4. Okay? We're not going to talk about the solar system while we're recording math. Number 2, Nora and Nick cut felt squares to make 6 equal-sized patches. Nick wants his patches to have a different shape but the same area as Nora's patches. Draw lines to show how they can each cut each of the felt squares. So divide those 2 squares into 6 parts. All right, several of us here in the classroom try to draw diagonally, and we cannot do that because when we go to cutting things in half to get 6, we now have a big portion here and a smaller portion here, so you cannot do that like that. So one of the easiest things to do is to cut it in half and then half each one, okay? Or you could cut it in half and then put 2 marks in each one.
That's not what I think.
Or you can take out some of the lines. You could do like we did a while ago and divide it into thirds and divide it in half. Or you could divide it into thirds this way. Whoops, wrong way. You could divide it into thirds this way and divide it in half. So there were several ways you could do that. Did everybody get it divided? Eli, you get it divided?
Why do you have to make sure it's when you have to make sure that it's
Well, because you can, I know that you can't draw it exactly equal. Mine weren't exactly equal, but you can do better than some of you did. Matt, put your book away. Huh? Oh, great. Now that all got on there. Okay, here we go. Number 3, construct arguments. Glenn says he can divide the 6-sided shape into 3 parts with equal areas. Emily says she can divide the shape into 6 parts with equal areas. Whose statement is correct? So let's use one of these for Glenn. Let's see. Can we divide this 6-sided shape into equal parts? I think we can because it's 6-sided. Okay? Now, can he do, that's Emily. Can you figure out how to divide it into 3 equal parts? How?
upside down Y?
There you go. There's 3 equal parts. It makes it look kind of like a box, doesn't it? Like a cube.
Oh yeah, it does.
So, whose statement is correct? What did we find out? They are both correct, right?
Yes.
The shape can be... Okay, if you are home, please try to do 4, 5, and 6 on your own and then come back to the video to see if you did them correctly. All right, so as you can see, here are your answers to 4, 5, and 6. Go ahead and check that and then move on to your homework.